Hi, in this question we are given two lines and we need to show that they intersect, find the point that they intersect as well, and find the equation of the Cartesian plane that contains both of those lines. So let's start with part A. So what I'm going to do is I'm going to take just the x pieces, I'm going to set them equal to each other, so that's 1 plus s equals 1 minus t, and I'll take the y pieces and I'll set them equal to each other. So that's 2 plus s, 2 plus 2s, and 5 minus t. I'll do simultaneous equations here. Actually, let's see here. Plus t here. Okay, so simultaneous equations, these are all ready to go. They're already opposite. So that's 3 plus 3s equals 6, and that goes away. Move the 3 over, we get 3s equals 3, s equals 1. Substitute that back right here, and we get 2 equals 1 minus t, which means t will be minus 1. Alright. So we already know they're equal on the x and y, given these s's and t's. So let's find out z. I need the whole coordinate though, so I'll plug in this right here into this equation. So plug in 1, and we get 2. Plug in 1 again, we get 4. Plug in 1 again, this is 0 minus 3, so that's minus 3. Okay, so this is going to be 2 and 4. We know that because we solved the simultaneous. Now let's just plug in t is minus 1 into that z part. See if it's minus 3. So minus 9, and then plus 6 is minus 3. Okay, so they intersect at 2, 4, minus 3. Now for part B, what I'm going to do is I need a plane. So I'll call the plane 2, 4 minus 3. I'll just have it start here, and then I'll take the direction vectors of both the lines, and that will guarantee that it contains both the lines. The plane contains both the lines. So the direction for the first one is 1, 2, minus 3. So 1, 2, minus 3. And the direction for the second line is minus 1, 1, minus 6. Minus 1, 1, minus 6. Alright, so now we've got the plane. All we have to do now is convert it into Cartesian form. So to do that, I'm going to find the cross product of its two direction vectors. So that's 1, 2, minus 3, minus 1, 1, minus 6. So 2 minus 6 is minus 12 plus 3, so minus 12 plus 3 is minus 9. So the way I do it is I do this, and then I do this, and then I do this. So it's like 3 fish, I guess. But when I do one of them, I end here at -3, and that's my starting point for the next one. And then I go backwards. Many ways to do it. So then minus 3 minus 1 is 3 minus -6. So 3 plus 6 is 9. And then 1 minus -2, or 1 plus 2, is 3. And this will be equivalent to, I'll just divide by 3. So we have -3, 3, 1. Alright, so this vector is perpendicular to the plane. It's perpendicular to both of these vectors, which means it's normal or perpendicular to the plane. So -3x plus 3y plus z equals d. And now I just need one point that's contained in the plane. I'll plug it in for x, y, and z and solve for d. And that one point will be 2, 4, minus 3, which is our intersection point. So minus 3, 2, plus 3 times 4, plus negative 3 will equal d. That's negative 6 plus 12 minus 3. So negative 6 plus 12 is 6, minus 3 is 3. So 3 equals d. So the equation of our plane is 3x plus 3y plus z equals 3. Hope you followed that. Here's our answer.